I want to show you how you can make a water bottle on Desmos. Before we get started, I recommend you get a reference photo for this video. It'll make it a lot easier to graph. And if you have one already, you can use the add item, click image, a dialog will pop up where you can load your image in, and by default it'll place it at um, at your graph's origin. If you want to use the same photo, I will put a link to the one on Pixabay. It's Creative Commons. The last time I checked, and so to avoid any licensing issues, that's what I search under, and that'll avoid any kind of copyright problems. So by default, this is at full opacity, and so I like to turn it down to half so it's not getting in our way. And for this example, the water bottle that we want to graph is off to the side, and so we do want to shift it over a little bit, and that's where you might want to adjust your just the center. Or we don't want to do that. I believe you can actually just click and drag. And try to center it to the best you can. Now, mind you that we're not going to try to be getting our lines exactly to match. That's just way too much. But rather to use this image as a guideline. I want to put this in a folder called reference, since we're going to be using folders everywhere in this graph. Yes, we did just make a folder just for one single image. If you have multiple, if you want to use multiple for whatever reason, by all means, you can absolutely have a remix design, or if you want to just make your own. I want to start with the lid. We'll start breaking this up a little bit. I'm gonna make one for the lid, and then I'll make one for the body. And for the lid, we're going to start by using an ellipse. We don't need the full ellipse, we just need half of it. If you want the top half, that's a positive value. So let's use, this is looking about half. And then we shift this up to about 4.5. And we can squash this a little bit. That's too much. If you want straight lines coming down the middle, what you can do is you can squash this by a lot. Let's move this up a little bit. It doesn't have to be exact. And then we'll add lines to the ends here. And for this one, let's end this around 4.5. So let's go 4.5, then y less than 4.8. And we can copy the same boundaries in here. I'm going to start with solid black lines, and then And eventually we'll delete the reference once we're done, and then we'll and then we can change the lines to whatever color you want. Black just contrasts very well here. Right, now I'm gonna finish off the lid here, and I'm gonna get this next layer down. And just to keep it simple, I'm gonna just do a straight line just going across, and we're going to have this overreach the ends by just a little bit. And now we found our two y values. Again, these are arbitrary. And so now we can do x is minus 0.55 and x is positive 0.55. And for this one is looking about 4.25. And we can go ahead and close these lines here. You can choose to arc it. I'm just going to just draw another straight line through. In fact, I actually do like the idea of drawing an arc, so I'm just gonna make another ellipse. So the width of this is 0.55, so we're not going to use 0.5 squared, so but instead we're going to use 0.55 squared. As for how much to add, we know at the bottom of this is 4.25. And we can freely squish this by however much we want. It's going to go just a little bit. Next, let's add in vertical lines coming from this end here. I will use the same value as. Actually, in fact, it's not this value here. We want to bring it by just a little bit. I'm also getting too caught up in the details. Let's not do that. Let's keep on eyeballing it. .45 actually looks really good. And this one, I want to get a few more decimal places, so I'm just going to zoom in. This is about 4.282. And this piece, let's pick a whole number. We're gonna end at about 4. Duplicate it, copy and paste it. We'll use the same equation on the other side. Now for this piece, there are two options here. We can actually, this is the one that I am preferring, which is to just go with a parabola, and then we'll have and then we'll just have a sharp transition going to a straight line down here. So positive coefficient will get your parabola pointing upwards. We want it pointing downwards. I'm just going to go with a negative value, and then we're going to adjust it until it fits this line. It doesn't have to be perfect, right? We don't want. I mean, it's a bit overkill to go with the deformations here. So we're going to shift it up until it looks like it fits. So I'm going to move it up, stretch it. We want just a little bit of overlap here. So now this is 4.015. All right, and now this is looking about 2.5. So we're gonna go there. Reason, yeah, actually let's draw that cutoff point. We don't have to. I am somewhat preferring this. I don't want to spend too much time, make a wire, shift it down. I don't want to spend any more time doing that. This is only for a tutorial anyways. Or maybe I'll shift it out just a little bit. I meant cutting it off. Then we want to find where's this cutoff point. This we can't be exact since we know what the y value needs to be. It needs to be. We need to find the x value here such that when we evaluate at this point we get 2.6, and we should end up with two values. I'm just going to take the positive value and just add a negative for the other line, and in that case I'm going to start with 2.6, subtract 4.15. I'm doing is grabbing this value, putting it here, then I'm going to subtract 4.15 to the other side. Multiply it by 1.5. This is part of this job as a calculator. Make it negative since this is a negative value, and then we want to take the square root of it. We don't need parentheses anymore for this case. Yep, and now we have the exact answer if you want to evaluate further. I mean, you can if you want. I'm just going to leave it as is. Then this let's just call this 1.7-ish. And that we know for sure it's 2.6. Copy it, duplicate it. If you take the square root of a positive number, you should end up with plus or minus. The next piece here is where things get interesting because we have all these bumps. If you want to vary them in sizes like this picture is doing, go for it. I'm just gonna keep it simple. I'm not gonna try to vary it up. What I'm going to do instead, this is probably the first deviation that they ever see. Just realizing that a lot of these equations are going to the body. I want I want to do that real quick, and then I will jump back and I'll show you how to do the bumps. All right. I put everything into the body folder, and also change the color just to have these sanity check that we grab the right equations. All right, for the bumps, the idea is we're gonna take a periodic equation. That's gonna be a little confusing. We'll take a periodic equation like this, and so that everything we want this bump here, but then we also want everything here to also have the same kind of bump. And so we do that by taking the absolute value of it, and now you can see everything's flipped upright, or just flipped over to the positive side. You want to change it if you want to make it a bit more flat at top. You can go for it. I'm just gonna go with a simple solution. I want this to be running. We want this, but happening on the vertical axis. So we do that by switching the x with the y, and now we got this going on, which is really cool. And I want to squash this vertically. So you can do that by multiplying the y-axis. And you want to for one squish this. At the same time, we don't want a bit of a more mild transition, I think. Don't want to spend too much time doing this. That actually helps. And maybe squish this a little bit more. Yeah, that's good enough for what we're trying to do. And this is approximately 1.5, so we could start with that. I'm going to scooch this in a little bit. I want to translate this down by a small amount. Alright, now we can move this to the right by a little bit. I'm gonna go with this. It might be mildly ugly, but it's good enough for what we're trying to do. So this value is 1.762. It's not 1.7 anymore. And then this one will now start from 1.762. And where this ends, we're going to decide that by drawing, I think just keep it simple. We're going to go with a parabola that's going to connect up here. And then we're going to go, and it will go with an ellipse that's going to connect the bottom. And that should complete our graph. So let's make let's add a parabola. We're going to shift this down by, we'll make it 5 for now, and then we'll fix it up a little later. Do want to squish this by just a little bit. Perhaps getting too caught in details is not the best idea in the world. And we're going to shift this over until it looks like it fits. All right, so this is going from, it's going to be everything to the left of 1.497. And this is going to be minus 4.029. That's where the y ends for this one. And let's make a second parabola. It's going to be the mirrored copy of this. Oh, let's copy this equation. And wanted to mirror it. I think we did that. That'll give us a mirror copy. Yes, it does. Okay, and now I can grab this equation and we're going to flip that over. And we also want to mirror this over. And so I think the quickest way of doing this is just to put a negative sign in front of this x, and it'll bring it over. Yes, it does. And this we can use a similar boundary. So it's going to be minus 1.497 is less than or equal to x. And now it's missing is just an ellipse to close the bottom there. We'll start with 1 minus x squared. We don't want the top, we want the bottom, and so we're just going to put a negative in front of it. And let's also just move it down by 5. We'll squish this. And we'll also try to stretch this. Maybe less of a squish at the bottom. And we'll move this up by a little bit. That's too much. That looks good enough for what we're trying to do. So this point is minus 1.132. Which must means that this, at these values, also 1.132. So that's going to bound the parabola that's completing the bottom here. And want minus this. All right, now we don't need our reference anymore. If you want it back, you can always just click this button. If you just want it gone for good, that's this button here. And if you accidentally delete it, just hit Control Z and you'll bring it back. And so now I'm good with making all the lines the same color. And that is how you make a water bottle. You can make one however you like. It's a good reminder to stay hydrated. If you found this video helpful, please consider leaving a like. And if you didn't find it helpful, please leave a comment below on what else you would have found useful. Yeah, other than that, thanks for staying on for the tutorial. Hope you benefited from it, and I'll see you in the next video.